Yes, Schedule 40 PVC conduit is acceptable for stubbing out of a cement slab. The National Electrical Code, specifically Article 352, which covers plastic wiring systems, addresses this. Section 352.56b concerning stub-ups provides the relevant information. It states that the approved Schedule 40 or 80 rigid non-metallic conduit shall be permitted to extend from the form or the concrete slab without the use of an extension ring, provided the length of the conduit stub does not exceed 600 mm, which is approximately 24 inches. Therefore, using Schedule 40 PVC for stubbing out of a concrete slab is permissible under the NEC, given that the stub-up length adheres to the specified limit. To further elaborate on the requirements and considerations when using Schedule 40 PVC conduit for stubbing out of concrete slabs, it's essential to understand the broader context of Article 352 and related sections within the National Electrical Code. Firstly, Article 352 covers the use, installation, and construction specifications for rigid non-metallic conduit, which includes Schedule 40 and Schedule 80 PVC conduit. This article is crucial for ensuring that the installation is not only compliant with the code but also safe and reliable. Secondly, the specific section mentioned, 352.56b, focuses on stub-ups. A stub-up refers to a short section of conduit that extends from a concrete slab or wall, providing a transition point for wiring. The NEC recognizes the need for these stub-ups in many electrical installations and provides guidelines for their proper implementation. The allowance for Schedule 40 or 80 PVC conduit and stub-ups is subject to certain conditions. One of the most important conditions is the length restriction. The code specifies that the conduit stub should not exceed 600 mm or 24 inches. This limitation is in place for several reasons. One reason is to minimize the potential for physical damage to the conduit. Longer stub-ups are more susceptible to being hit, bent, or broken, which could compromise the integrity of the wiring system. Another reason is to prevent excessive stress on the conduit and its connections. Longer stub-ups can exert more leverage on the point where they emerge from the concrete, potentially leading to cracks or other damage. Furthermore, the NEC emphasizes the importance of using approved materials. This means that the PVC conduit must meet specific standards for quality and performance. Approved conduits are typically listed by organizations such as Underwriters Laboratories, ensuring that they have been tested and certified to meet the required safety and performance criteria. When installing PVC conduit as a stub-up, several best practices should be followed. One best practice is to ensure that the conduit is securely anchored to the concrete. This can be achieved through the use of appropriate clamps, straps, or other fastening devices. Proper anchoring prevents the conduit from shifting or moving, which could strain the wiring or create a safety hazard. Another best practice is to use conduit fittings that are specifically designed for use with PVC conduit. These fittings provide a secure and watertight connection between the conduit and other components of the wiring system. It's crucial to select fittings that are compatible with the size and type of conduit being used. Additionally, it's essential to protect the stub-up from physical damage during and after construction. This can be accomplished by using protective sleeves guards or other measures to shield the conduit from impact or abrasion. In areas where the stub-up is exposed to vehicular traffic or other heavy equipment, extra precautions may be necessary. Moreover, the NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that the installation should be visually appealing and free from defects that could compromise safety or performance. Conduit runs should be straight and parallel, and all connections should be tight and secure. In addition to the specific requirements for stub-ups, the NEC also addresses other aspects of PVC conduit installation. For example, Article 352 includes provisions for conduit support, bending, and joining. It's important to consult these provisions to ensure that the entire installation is compliant with the code. Conduit support requirements vary depending on the size and type of conduit, as well as the spacing between supports. The NEC specifies the maximum allowable spacing for different conduit sizes to prevent sagging or deformation. Bending PVC conduit requires the use of specialized tools and techniques. The NEC sets limits on the radius of bends to prevent damage to the conduit and to ensure that conductors can be easily pulled through. Joining PVC conduit involves the use of fittings and adhesives. The NEC requires that these materials be compatible with the conduit and that they be applied according to the manufacturer's instructions. When working with PVC conduit, it's also important to be aware of its limitations. PVC conduit is not suitable for all applications. For example, it should not be used in areas where it will be exposed to high temperatures or corrosive chemicals. In these situations, other types of conduit, such as rigid metal conduit, may be more appropriate. Furthermore, PVC conduit is not as strong as metal conduit, so it may not be suitable for applications where it will be subject to heavy physical stress. In these cases, Schedule 80 PVC conduit, which is thicker and more durable than Schedule 40, may be a better choice. It's also important to consider the environmental conditions when selecting PVC conduit. PVC conduit can become brittle in cold weather, so it may not be suitable for outdoor installations in extremely cold climates. In these situations, other types of conduit, such as high-density polyethylene conduit, may be more appropriate. In summary, the use of Schedule 40 PVC conduit for stubbing out of concrete slabs is acceptable under the NEC, provided that the installation complies with the requirements of Article 352, specifically Section 352.56b. This includes adhering to the length restriction of 600 mm or 24 inches and using approved materials and installation practices. By following these guidelines, you can ensure that the installation is safe, reliable, and compliant with the electrical code. Remember to always consult the latest edition of the NEC and any applicable local codes before beginning any electrical work. It's also a good idea to consult with a qualified electrician if you have any questions or concerns about the installation. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. Staying up to date with the latest edition of the NEC is essential for anyone involved in electrical work. In addition to the NEC, many local jurisdictions have their own electrical codes. These codes may be more stringent than the NEC, so it's important to be familiar with the local requirements before beginning any electrical work. It's also important to obtain any necessary permits before starting an electrical project. Permits ensure that the work is inspected and approved by a qualified electrical inspector. Electrical inspections help to ensure that the installation is safe and compliant with the code. When performing electrical work, it's essential to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It also includes energizing circuits before working on them. The energizing circuits prevent electrical shock, which can be fatal. It's also important to use properly insulated tools when working on electrical circuits. Insulated tools protect you from electrical shock. Furthermore, it's essential to be aware of the potential hazards associated with electricity. Electricity can cause fires, explosions, and other accidents. By following safety precautions and using common sense, you can minimize the risk of these hazards. If you are not comfortable performing electrical work yourself, it's best to hire a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. Hiring a qualified electrician can save you time and money in the long run, and it can also help to prevent accidents. When selecting an electrician, it's important to check their credentials and references. Make sure that they are licensed and insured. It's also a good idea to get multiple quotes before hiring an electrician. This will help you to ensure that you are getting a fair price. In addition to the specific requirements for PVC conduit stub-ups, the NEC also addresses other aspects of conduit installations, such as conduit fill. Conduit fill refers to the amount of space that is occupied by conductors inside a conduit. The NEC sets limits on conduit fill to prevent overheating and to ensure that conductors can be easily pulled through the conduit. The allowable conduit fill depends on the size and type of conduit, as well as the number and size of conductors. The NEC provides tables that specify the maximum allowable conduit fill for different combinations of conduit and conductors. It's important to consult these tables before installing conductors in a conduit. Overfilling a conduit can lead to overheating, which can damage the conductors and create a fire hazard. It can also make it difficult to pull conductors through the conduit, which can damage the conductors and increase the risk of injury. In addition to conduit fill, the NEC also addresses the issue of derriting conductors. Derriting refers to reducing the ampacity of conductors to account for factors such as ambient temperature and the number of conductors in a conduit. The NEC provides tables that specify the derriting factors for different conditions. It's important to apply these derriting factors to ensure that conductors are not overloaded. Overloading conductors can lead to overheating, which can damage the conductors and create a fire hazard. The NEC also addresses the issue of grounding and bonding. Grounding and bonding are essential for preventing electrical shock and for providing a path for fault current to flow back to the source. The NEC specifies the requirements for grounding and bonding electrical systems and equipment. It's important to follow these requirements to ensure that the electrical system is safe. In addition to the technical requirements, the NEC also addresses the administrative aspects of electrical work. This includes requirements for permits, inspections, and documentation. It's important to comply with these administrative requirements to ensure that the electrical work is properly authorized and inspected. The NEC is a complex and comprehensive set of standards. It's important to consult the NEC and any applicable local codes before beginning any electrical work. It's also a good idea to consult with a qualified electrician if you have any questions or concerns about the installation. Electrical safety is paramount. Always prioritize safety when working with electricity. Follow all safety precautions and use common sense. Electricity can be dangerous, but by taking the necessary precautions, you can minimize the risk of accidents. Remember, the information provided here is for general guidance only. It's not a substitute for consulting the NEC and any applicable local codes. It's also not a substitute for consulting with a qualified electrician. Always consult with a qualified professional before beginning any electrical work. They will be able to assess the specific conditions of your installation and provide you with the best advice. Staying informed and taking the necessary precautions will ensure a safe and compliant electrical installation.